researchers and professionals for this 5-day faculty development program on recent advances in the civil engineering. Dear participants, civil engineering has always been the backbone of infrastructure development, but what set today's era apart is the speed of innovation. From the smart material and AI-based design tool to the sustainable construction practices, I think these advancements not only the demand our attention but also inspire us to rethink, relearn, and reform how we approach education and industry needs. I sincerely appreciate the efforts of the Civil Engineering Department of Rajshree Institute of Management Technology, Bareilly, for organizing this faculty development program in collaboration with the Institution of Engineers India, Bareilly Local Center. Your initiative reflects a strong academic vision and deep commitment to faculty empowerment. I encourage to all the participants to mark this opportunity with an open and curious mind, learn not just from the expert but also from each other. Share experiences, ask questions, and think about how you can apply these insights in your classroom, research, and field work. Let this week not just about gaining knowledge, but about building a community of continuous learner and innovator. Wishing all fruitful and intellectual enriching faculty development programs. Thank you very much. And also welcome today's speaker, first speaker, Professor Akhilesh Kumar Moraji, Department of Civil Engineering, IIT Guwahati. So thank you very much, sir. You are most welcome in this FDP. Thank you.
Yeah, thank you, Professor Pankaj, for welcoming
Thank you,
me.
sir.
Thank you so much, Director Sir, for inspiring your words. Now, I would like to extend my warm invitation to our respected Director Academic, Dr. Anil Kumar, to address the gathering. Dr. Anil Sir has continuously guiding our academic endeavors with great dedication and vision. His support has been instrumental in fostering a culture of continuous learning and academic excellence within our institution. Sir, we are grateful to your presence and we now request you share your thoughts and insights with honors. Welcome, sir. Sir.
Good afternoon, one and all. I am Dr. Anil Kumar, Director Academic of Rajshree Institute of Management and Technology, Bareilly. Distinguished guests, esteemed faculty members, and the organizers, it is my pleasure to welcome you all to this 5-day faculty development program on recent advancement in civil engineering. We are honored to have expert and faculty members from all over India joining us for this program. In today's rapid evolving world, civil engineering is witnessing significant transformations with advancement in technology, materials, and sustainability. This program aims to provide a platform for faculty members to update their knowledge, share their experiences, and learn from each other. Over the next 5 days, we will explore the latest development in civil engineering, including innovative materials, cutting-edge technologies, and sustainable practices. Our esteemed speakers will share their expertise and we will engage in thought-provoking discussions and deliberations. I would like to express my gratitude to the organizers, speakers, and the participants for their efforts and contributions to make this program a success. Your participation will not only enhance your knowledge, but also foster collaboration and networking opportunities. I wish you all a fruitful and enriching experience during this program. Let us work together to make this a memorable and impactful event. Thank you, one and all.
Thank you, sir. Dr. Anil sir has your thoughtful and encouraging words. Your guidance and academic vision continue to inspire us in our pursuit of quality education and innovation. We truly appreciate your support and presence in the faculty development program. Thank you once again for your valuable contribution, sir. Now, I would like to invite uh, Teen Student Welfare, Dr. Ravi Agrawal, sir.
Good afternoon, Anuj. Good afternoon, Honorable Resource Person from IIT and NIT, all the dignitaries and participants. It gives me immense pleasure to welcome all of you to the inaugural day of 5-day faculty development program on recent advancement in civil engineering, organized by Department of Civil Engineering, Rajshree Institute of Management and Technology, Bareilly, in association with Institution of Engineers India, Bareilly Local Center. Let me give brief introduction about the Rajshree Group of Institution. Rajshree Group of Institution Bareilly is established under the renowned Rajshree Educational Trust under the strong vision and leadership of Chairman Shri Rajendra Kumar Agrawal and Secretary Shri Rakesh Kumar Agrawal ji. Rajshree Group has diversified into various verticals like education, manufacturing, infrastructure development, real estate, agriculture, health, medical, and societal development. It has widened its spectrum built on a strong foundation of ethical and social values. Rajshree Group made a mammoth leap in the education arena by establishment of Rajshree Institute of Management and Technology in 2009. Today, it is an ISO 9001-2015 certified institute and has ranked among top institutes in the country. Presently, the group is running 12 prestigious educational institutions in Bareilly and offering various postgraduate, undergraduate, diploma, and certificate courses in engineering, management, medical, education, science, art, commerce, law, nursing, ITI, Ayurveda, polytechnic diploma, etc. It has 1,050 bedded multi-super specialty medical hospital, 60 bedded Ayurvedic hospital, and a world-class Panchkarma, yoga, and meditation center. This FDP has been designed to enrich and update the knowledge base of faculty members and researchers with student cutting-edge development in the field of civil engineering. Over the next 5 days, we'll be engaging with the experts from the premier institutions who will share insight on emerging trends, technology, and research innovation. Today, on the day one, we are truly honored to have with us two distinguished speakers, Dr. Akhilesh Kumar from IIT Guwahati, followed by Dr. Chandan MC from NIT Karnataka. We are grateful to them for taking time out of their valuable schedule to be with us today. I extend a warm welcome to all the participants, dignitaries, faculty members, and our esteemed speaker. Let us make this FDP a meaningful, interactive, and impactful experience to all of you. Thank you.
Yes, sir. For your for introducing about the Rajshree and motivation and insightful words. Now, I feel privileged to introduce our esteemed speaker, Dr. Akhilesh Kumar Maurya, sir, who will be delivering the first session of the faculty development program. Dr. Akhilesh Maurya, sir, is a professor in the Department of Civil Engineering at Indian Institute of Technology, Guwahati. He holds PhD in civil engineering from IIT Kanpur. His primary research interest includes traffic flow modeling, driver behavior analysis, road safety audits, accident analysis, and transportation data analytics. He has over a decade of academic and research experience and has published more than 90 papers in the reputed international journal and conferences. Dr. Maurya sir has led several major sponsored projects, including the development of Indo-Highway Capacity Manual and GPS-based traffic flow measurement system. He has also provides consultancy for various infrastructure and road safety projects across India, particularly in the northeastern region. He has certified road safety auditor and has been actively involved in the policy level and field level transportation planning. Internationally, he has been a visited scholar at institutions such as TU Damset and National University of Singapore and has received prestigious DAD Fellowship. Dr. Maurya sir is the president of Transportation Research Group (TRG) of India and life member of the Indian Road Congress. His contribution significantly impact traffic engineering and transport planning in India. Thank you, sir. And now, am I audible, sir?
Yes, I can hear you.
Yeah, okay. Thank you, sir. May I invite now Dr. Akhilesh Kumar Maurya, sir? Please, sir.
Yeah. So I'm sharing the screen. So whether my screen is visible?
Yes, sir.
Okay. Yeah, it's a full screen mode.
No, sir.
Whether now you are able to see my full screen?
Yes, sir. Yes, sir. Now is okay.
So whether it is changing?
Yes, sir.
Okay. Okay. Good afternoon, all. So whether I am audible to all?
Yes, sir. Good afternoon, sir.
Yeah. Okay. So first of all, I thank you, Dr. Anuj, like maybe for inviting me
Thank
for
you,
this
sir.
FDP course. Yeah. And the Rajshree group of institution.
Thank you, sir.
So already you had given the elaborated introduction. So straightforward, I can start with the content. So this like so as this FDP is on like recent advancement in civil engineering. So if we see last 2 decades, there are large amount of like variety of development has been taking place in all sectors of the transportation, not only transportation, maybe all sectors of the civil engineering. If we see that like that particular sectors where this advancement happened, so it's like maybe material and construction related, technology related, then digital and automation related development, smart infrastructure related development, then sustainable and environmental engineering related development, then even AI data and computational modeling related development taking place, and transportation and urban planning. There are a lot of autonomous, including autonomous vehicle, many other development take place. So here, my today's focus will be like mostly on two aspects. So as my title says that like AR, VR and autonomous vehicle. So, but like, let us go through that, like some of the important development which has been taken place in all other sectors. So, yeah. So, like this is one of the development which is recently going on. Like maybe you can have future concrete which can be of self-healing. If the crack gets developed, it can heal automatically. So imagine like you have a building which does not have a crack even after 20 years, 40 years, 50 years. So that kind of advancement is like people are working on. Then even similarly in road area, people are trying to develop a kind of mix which can heal by himself. So you in future you may see roads which may not crack at all, or even if crack occurs, it might automatically heal itself. Then even monitoring of the bigger building, especially high-rise building, become quite challenging because you cannot reach each and every corner of the building. So now using the drone, it become quite easy. You can like record the entire building and develop the 3D model that what kind of construction happens periodically. So every week or every day you can record and see that actually how much construction happened. And even like these drone monitoring become like quite important if it is a kind of sea structure, like maybe if it is a bridges, like through certain part of bridges, it is become very difficult for human to reach there. But through drone, you can like see a high quality image of each and every corner of the bridge. So that is like become another advancement which become quite handy in all areas, not only in this project monitoring. Then other aspect like now it become modular construction. So earlier we were more familiar with the modular kitchen, which is basically comes in pieces and you can assemble at your house. But now in similar way, the way you assemble might have assembled in dollhouse at your home for your daughter, but the even bigger house can be assembled in future. So all the component is like getting developed or furbished at the company, and then their parts can be assembled quickly at the site, and each and every specification will be so detailed that it will automatically get fit at that location, and all the other locking arrangement will be already in place. So that way, like fabrication can be quicker. So and quality can be controlled, which is another important aspect, because like the quality control become a big concern nowadays. Like if you have on-site construction, until unless you have very strict supervision, quality control can be a big challenge. So then 3D printing. So whether my slide is like still moving? So you are able to see 3D printing slide?
Yes, sir, visual, sir.
Okay, good.
Yes,
Thank you
sir.
for confirming. Yeah. So 3D printing is another entirely like growing area. So it started with the small 3D printing with the certain small component of the different machinery, and maybe you can build even the entire house or maybe office complex. So this is like one of the 3D printed security barrack which had been done at IIT Guwahati. So it's fully 3D printed except this roof. And it is like completed within 1 or 2 days. So imagine like the kind of uh, rate at which you can construct this kind of structure. So the construction become like quite fast with this 3D printing. Even you can design various complicated structure through 3D printing, which is become very challenging in other way in routine traditional construction. So in transportation, again, like there are like various development taking place. You might have heard of like Hyperloop project, where you can have like your pods which can travel at more than 1,000 km/h speed. So kind of Pune and Bombay distance can be traveled within 30 minutes, which is currently taking 3 to 4 hours. So imagine what kind of a revolution you are going to see in next 5 to 10 years And these things, many of these things will become part of your life, which is currently looks like quite fancy, or maybe like kind of looks hypothetical. But people are working on it, and they are like soon will be part of your real life. Then the another development is like taking place towards the eye tracking. So where like you can track your eye movement, your dizziness, whether you are concentrating or not, whether you are diverted or not. So this is like a very big role in driving. While you can, through eye tracking, you can do the monitoring of the driver, whether he is fall sleepy or he is focusing on all the signage or not. Even these things are like become a boon for the like people who do not have like are disabled people who does not have hands. Still they wanted to work on certain maybe wanted to use computers, or you wanted to have some modern gadgets. So through eye tracking they can like do all such things which like other normal person do by their hands. So that way, like eye tracking become like another area where like multiple use can be explored. Then you're like through a smart city program, now many of the even parking things becoming smart. So maybe in future, because like now in most of the cities, like parking become a big problem. Once you go for shopping, if you get parking, then you might be lucky one. So with the technology might be happen like you can book your parking in advance, or maybe you can access the parking lot and see that like whether the parking space is available or not. So through these sensors, like they can keep monitoring whether vehicle is present or not, and then all the data can keep disseminated and get collected to a server, and which might be available through apps. So you can just simply put your destination, and you will be able to see that what are the nearby parking lots. Click on those parking lots, you will be able to figure it out how many slots are available. So that way you can plan very well, or maybe in future, if it is maybe if it can, somebody can take it up further, you can book those slots in advance, so that like before you reach, your parking slots are already booked. So that way, a lot of innovation is going on in every field. So today we will be talking about only AR/VR technology, augmented reality and virtual reality technology, and autonomous vehicle, which have become like kind of a very fantasy word earlier, 5 to 10 years back. People were not believing that like the such kind of car can be a reality, but now it is reality at certain part of the other country. But soon it will be you will be witnessing such cars in your road as well. So if we talk about like AR/VR technology, so augmented reality and virtual reality, these are two different terms. They had like different approach, different meanings. In augmented reality, you are exposed to the real world. You will be seeing the real world. On the top of that, certain other digital overlay will be placed, which will give you some additional information. So like maybe if you are a particular place, if you are new, so maybe your father or maybe another your friend who can keep guiding, okay, this building is this kind of historical important, that building is this historical important, this particular shop, even if name suggests like maybe you are not able to read or understand their language, it can keep he can keep telling that what kind of shop it is, what kind of facility it gives. But imagine like if you are traveling a unknown place where nobody is there. So this kind of technology will help you. You will keep seeing through those glasses, and wherever you turn, all the building will be visible. On the top of the building, you will have additional knowledge that, okay, this building name is this and built on this year, and blah, blah, all the information, whatever you wanted to convey to the user. Like here, so if this is a building and maybe you wanted to make this kind of a structure. So, but you are not sure that how this structure will look like once you build. So you cannot afford that, like you build a structure and see that, okay, it doesn't look at this corner, let us like dismantle and build it somewhere else. That is just a foolish decision. So with this, like maybe you AR, you can build it virtually and see that how it will look like. If it doesn't fit your existing particular location, you can try it and some other location and see that like whether it goes well in sync with the existing structure or not, and then decide the location. So that become quite handy. So imagine that like maybe once you go to your a property broker, they always like if you approach him like very early stage, they will say, okay, now I will show you your like flat location. And once you reach there, you will see there's just a barren land because nothing had been started. So for you, it becomes very difficult to imagine that how that building will look like at that particular location. But now they can come up with this VR technique. Like if you wear that glass and you will see that like where all each and every pillar will come and how they will look like. You can keep moving the entire area and you can see that like what kind of structure will be there at that location. So in a way, like you will be traveling in real world. World. Yeah, yeah. Can I ask all the participant to mute, please?
Muted, sir.
Yeah, thank you. So in these cases, like maybe with the help of AR, you will be traveling or you will certain devices either in form of tab or in form of mobile, you can visualize. Once you focus that tab in particular location, geocoded location fitted into it, it will start showing the structure which will come at that location. Then technology. So we are reality. Everything is virtual, and then you will be going through that virtual world. You are driving on the car, but in every environment which you are able to see this kind of your VR headset, that will be Then in case of like AR, that is like because it is having a real world, and you need to just supplement some of the digital overlay. So cost is lower, but in case of VR, you need to build the entire environment, so cost will be slightly higher. Now, through this like AR, we wanted to utilize in civil engineering. So where like maybe it helps in like advancing your visualization. It helps in like monitoring the construction or management. At the same time, it helps in a lot of training activities. We will see some of the examples, like even including fighting, or maybe even construction safety. All the training can be done like with using VR setup. Yeah. So like this is one example of kind of a city where if you are seeing through the VR equipment, either your tab or maybe with VR glass, you could see that like even all the places they are marked. What kind of office space, what kind of this, what are the different facilities. So even if you are new to a particular place, you can see all of this. Apart from that, like even it's not that like only it can be used only for that purpose. And you can see these all lines are like visual. So these might be your water line, or it can be electric cable line. This can be overlay, and you can, being engineer, you can easily pursue or perceive that like how the lines are laid. And then you can decide that, okay, if new line is going to come, how it will be, in what manner you can lay. So that way, without like digging up anything, you may able to see the entire pipe network or maybe electrical network in the real scenario. So like here also. So similar, like you can see that all these lines, and all those lines will be visible through only device. In actual, it will lines will not be visible. All this photo will be visible here in the device itself. Once you orient in which direction, whatever actual additional information has been laid, that will be like get on the top of the existing scenario. Then like imagine many of the cases you will see that like a architect will build a physical model of any office, and those things are bigger project. And that once clients come and he will demonstrate, okay, this will be the your CEO office, this will be like your common working place, this will be like a canteen, all those places he will keep telling you. But even if you are having a modern version, so which is like included with AR, so everybody will be able to see that like where car parking will be there, where like a rainwater system is installed. All those things which are already exist in the model are will be built in future. Everything will be visible altogether without any assistance. So that is the power of VR. Like you can explore through VR. Like here, if you had a kind of map, just say like your house map, you can visualize that how it will look like in 3D. So you have only 2D map, but if it is like built through AR, so maybe like once you through that software, see that software, that drawing through that software, you will be able to see that, okay, once your house will be built on this map, it might be looking like this. So that becomes like quite easy and convenient to visualize. So that is become very powerful tool. This AR become to help people in visualizing certain different things. Then you can visualize like all the network, like maybe which I had just told. Maybe like you can have in AR, you have entire township network, and then you keep walking through, and you will be able to see that how the drains had been, or water pipeline had been laid in entire your establishment. Then this driving. So while you are driving, if you had AR assistance, so what will it will do? that maybe some of the signboard which might be slightly far and you might have missed that signboard or you had not seen, it will automatically record those signboard and flash it in front of you. That okay, so like maybe in actual signboard whether you miss, but this flashing thing you cannot miss. So that way, if there is a certain speed restriction or certain sharp turn which is like kind of create hazard, if you miss those information, those can be put in AR format, so that like once you drive, you will be keep getting alert through AR at crucial location. Then it's come to the virtual reality, where like maybe you do not have anything physically, but you wanted to visualize that okay, how your house will look like once it's built. So maybe then a model can be built in VR, and then you can visualize, you can rotate, you can get into that house, walk through the house and see that like all those facilities you can inspect from inside. So that way, like it become a very quite immersive experience that you will be able to see your house before actually getting it built. So that will give you very clear idea, even all wall colors, furniture location, every detailing can be done, so that you can perceive each and everything in very detail. Then this is another use, like if you are planning like housing complex or maybe a particular industry. So you can have the, instead of building the models physically, so sometimes it becomes quite challenging that if you build the model physically, because if it is a big house, that becomes like quite time-taking job. And maybe there the particular scale is fixed, you cannot zoom it. But if you make the VR model, you can zoom any part and see that like how it will look like. If you want to have a closer look, you can zoom that particular location and see that how it will look like. So entire township can be visualized without having any physical model. So, and then the same technology can be used for multiple training program, multiple educational program. Like these all kids might be, they might be learning like how drone can be fly. So I don't know, maybe like whoever had flight the drone, they will see that like initially once you start learning and if you are not trained enough, so your drone will free fall and jump, like fall on the stuck in the ground, and maybe most of the time some part or other will get broken. So even in my kids case, like we purchased 3 of drone, and none of them like last more than a 1 day or 2 day, because like he is new, and like if you are not properly handled, the drone will like struck the ground at free fall at a very high speed, and then it will get broken. So now with this, we are like without touching the drone, you are have your virtual drone, which you are like using your like control, and then you are trying to learn that how to work with those controls so that drone remains high, and you can direct the drone as per your desire. So here, like maybe initially one time you might have made investment while developing the entire virtual setup, and subsequently like there is no investment. Like people can learn even if you don't have any physical drone. So they become quite trained, and once they have the actual drone, they might be able to drive it or handle it. It's much better confidence. Similarly, like one of the use cases which is going on at multiple locations where you can have VR-based driving simulator. So now it is like even certain DTOs, like it become mandatory that you have to go for simulator training, whether it can be VR, it can be a screen, both are like similar. So where you, instead of like going directly to the physical road, you have to go through that like simulator training. So then you will have actual steering, brake pedal, all those setup, and then you will be training yourself. And in this like setup, there might be certain scenario inbuilt. Once you drive, you will see that suddenly a signal will come, or a sharp turn will come, maybe another vehicle will come suddenly, a pedestrian will come. So all those scenarios which you see in the real life, that can be incorporated in this virtual world, so that like you can be trained for each and everything, so that you know that like when to apply brake and what extent of brake you need to apply at particular scenario. So this thing, and like here, even if you did do any mistake, nobody will get hurt, and even the infrastructure or your vehicle will not get damaged. So that is the best part. Like you will get trained up to certain level before you go actually on the ground. Because once you drive on the road, and if you are unskilled, then it's not that like your life is under risk. There are other people who are on the road, their life will also under risk. So you have no right to like make others life into risk. So that's why like these kind of VR based driving simulators become very important in like training people. Then even like you can do all this like welding business, or like firefighting, or maybe even the many of the how to operate this excavator. All those things can be trained. People can be trained through VR environment. Even the certain scientific instrument like maybe total station, those things also people can get training, even though you don't have any total station, but like they can get feel of that equipment and see that like how it operates. So they will be so trained that like if next day if they get the instrument of similar model, they will be able to operate. Then even like you can work as an engineer of pipe network, you can see that like how pipe connection can be done, and like maybe if any leakages happen, how to treat. All those training can be done through VR environment. So any question in the VR, or maybe like well, let us complete first and then we will have all the questions. Anuj, whether that will be okay?
Yes, sir. Okay, sir.
Okay.
Have any
So
query?
now,
Have any query?
yeah, you can.
Please ask.
Yeah, maybe we'll ask, we'll answer all the queries in the last, and maybe if you want, you can write all your queries in the chat box as well. Now the other part, like which is like you people might be more interested in autonomous vehicle. What does it mean, autonomous vehicle, and how feasible it will be in our condition. So autonomous vehicle might be kind of a vehicle which has like no driver, or maybe a driver does not do anything, and it's keep driving, keep on identifying different uh, vehicles which are present in the surrounding, and keep making decision like the human driver do. So that way, like maybe in future you may see that like there might be a road for autonomous normal vehicle, there might be road for autonomous car, or they can drive in between, makes up like as good as like normal driving car. So these are like built for a reason. Like over the time, you will be there will be a lot of people who might be either growing old, or you might not be available to drop your kid, or maybe a new location. You may not know each and everything. So in these cases, these autonomous cars become quite handy. So they will take you from point A to point B, which you had fed without any error. So that way, like you don't require like any manpower for those kind of vehicle to drive. So you can call the vehicle, it will come to your doorstep without any driver. It will take you to your destination wherever you ask for. So this is like a schematic diagram of autonomous vehicle. So here they had on the top, they had lidar, which will like keep rotating at multiple hertz frequency, so that it can keep scanning the surrounding. Apart from that, you will have multiple camera in front. Even there will be in bumper, you will have multiple radar, which will keep measuring the distance of nearest obstacle. Even all along the road, all along the vehicle, you will have these kind of radar or various different kind of sensors on board, which will keep on measuring the neighboring obstacle information and keep on fetching to onboard units where all the data will get collected through LiDAR, through camera, through radar. So multiple sources, they will collect the data and process it, and then they will take the decision. So that like it can work robustly, even if camera is not working, LiDAR can provide the data. Even if the radar started malfunctioning, it can get cross-checked with the camera, or it can get cross-checked with the LiDAR. So you have multiple sources of data to make a common decision, and that way, like it become quite effective. That you will not make any mistake in this case, and you will have like kind of correct information of your surrounding. So this is like one of Google car, which initially had been tried. So you could see that like LiDAR, apart from that LiDAR, how many different cameras are there, and that will keep on rotating and keep collecting the data in different parts. Okay, so now once we say that autonomous vehicle, like maybe your assumption is that like autonomous means like there is no driver at all. But there are different level of autonomous vehicles, which is starting from level 1 to level 5. So in different level of autonomous vehicle, there are different facility which a vehicle provide. Like first two level, we call it ADAS, and that become now very common. So any high-end car, if you consider, which will be like maybe above 10 lakh, you will see that will come with the ADAS system now. So what it say that like advanced ADAS means advanced driver assistance system. So it actually helps you in certain aspect, like maybe if you're moving too close to the next vehicle, means the vehicle which is ahead, and if you're moving at high speed and we are moving too close, it will start giving alert that if you don't take action, it will you are going to hit. Similarly, like in certain cases, like even it can apply brake if you are not applying brake. So that become like kind of level 2 ADAS. So where like if you are moving closer to the leading vehicle and maybe at very high speed, and it is anticipated that if you don't change your speed, you are going to hit that vehicle. So in that case, initially alert will come. So there are different alert level, mild, then medium, then hard. Different beeping will come. If you don't act on those alerts, so it will automatically apply your brake, and vehicle will stop before hitting the leading vehicle. So imagine that like now you will have the vehicle which you cannot like hit intensely to any particular object or maybe next vehicle. So automatically it will take care, because there are ADAS inbuilt, either radar-based ADAS or maybe video-based ADAS, which will keep looking in front direction and keep measuring the distance between the leading vehicle, your vehicle speed, and then keep on measuring the safety. And even once you are changing the lane, if you change the lane without giving the kind of indicator, it will warn you. And maybe like in certain cases, it will restrict you to the same lane if you're not giving indicator. So that way, like subsequently, if you had like level 2 ADAS, so maybe you can leave your vehicle and leave your feet off, and it will keep driving and keep following next vehicle, and it will keep on adjusting your vehicle's speed depending upon the leading vehicle speed. So that way, like you need not to worry about those kind of unexpected situation. Vehicle will automatically take care of. Then next comes like level 3, where steering control is also taken up. That way where we start talking about like now autonomous level has been increased. So where you need not to keep on changing a steering angle, and automatically consider the your steering, and based on if you leave and you had started cruise control, and then automatically it will follow the next vehicle and keep on moving in the same lane. It will not change the lane until unless required. So that way, like your in level 2, your feet actions are not required. Level 3, even your hand actions are not required. But still, you have to be alert, because these will be get activated only at if you are moving 50 kilometer or maybe higher speed. So it will work only in higher speed. Lower speed in congestion and those things, it will not work. So it has to be it will get activated only in that high speed. So, but like maybe then next level of automation, if you go, so maybe like even you need not to think of, it will like keep on making all the decisions. So automatically it will change the lane, it will change this, decide the speed, everything he will be doing. So still, it will keep on asking you at certain interval that you keep on touching your steering angle at certain regular interval. So assuming that you are alert. So because still it does not have 100% control of your car. But if you go to level 5, so it says that like you need not to bother about the car operations. So automatically it will take care of each and everything, all the driving aspect, it will take care. So it's like 27, what we say is like 27 means like we may start seeing in Indian roads. So bits and pieces, you might keep getting news clips that like some companies they are testing. But at various other country, automatically this like kind of automation is like autonomous vehicles are in place at certain location with certain restriction is going on. So now if we see what kind of challenges, so maybe like why if we had talked about like all these autonomous, if other countries already started using autonomous vehicle, why we cannot have this autonomous vehicle in India immediately? Because if it is available, that same car can come here and start working. But that is not that easy. There are certain challenges with if this kind of if this kind of dilemma thing come, then it become quite challenging. Still, we don't have any well accepted answer that like whom to hit. Different people might have different logic, but over the time, like based on the data, is once you keep collecting large amount of real life data, then these decision might become very easy. Then other major challenge which restrict the use of autonomous vehicle is the price. This level of autonomous vehicle pricings are very high, but sometimes like for Indian market, it become too high. Until unless this technology become very common and like mass production is started, so prices will not going to go down. So many of the people, even though it comes in the Indian market, many of us will not be able to afford it because there are huge amount of investment in R&D as well as even in regular operation, maintenance, all the sensor equipment which you use, that requires a lot of cost. So which you need to once you try to purchase this car, you need to pay for it. Then Other issue, which is like also people keep flagging. So once your phone get hacked, your like Gmail get hacked. So here also like many things are like over internet, they keep collecting the information. And suppose like you are driving your vehicle, maybe like your vehicle is driving you, and somebody hacked your vehicle itself. So maybe instead of reaching your destination, you might be reaching to the like kidnapper's place. What will happen to that? So there are like people are working on the this kind of cybersecurity aspect also, so that it become foolproof. So people get enough faith that these kind of security breach will not happen. Then other scenarios, like maybe in certain cases, like if like say if you are in your northern place, like then imagine a like winter December last or maybe early January kind of month where like it is dense fog, nothing is visible. So in that cases, like if some information, whatever is the bare minimum information required by the autonomous vehicle, if it is not available, it might stuck. It might remain standing in the middle of the road. So those kind of challenges might happen. So still you need a robust mechanism or multiple. That is why like you could see that there are different variety of sensors. Some are visual, which is like camera, some are lidar, some are radar. So which can ensure that certain level that all case of all variety of weather condition it can work, but still it needs to be verified, or like maybe it needs to be worked out, well experimented, and a foolproof algorithm needs to be done. So then like maybe and once these kind of cars are there, maybe and they will like keep collecting the information, and at the same time they will keep disseminating information also. So maybe like if you keep moving in this kind of technology domain, so there are like vehicles which will keep talking to each other. So talking means like once you are like moving in roads and suddenly if driver applies the brake, it will keep disseminating the information that I am going to brake, I am going to brake. So all subsequent and surrounding vehicle will receive that message and start flashing that like next vehicle is applying brake. So that way like they are communicating with each other, and at that information which you are getting right now maybe through brake light and some other means or visual means, you can keep getting with this kind of ways also, where vehicle itself is telling that I am going to brake. So those kind of scenario will also be there. Vehicle where vehicle will keep on talking to each other. So there are like various location where these vehicles are like already in use, and they're like autonomous vehicles for different either maybe and certain dedicated purpose, or maybe even in public domain. Autonomous vehicles are like started getting used in different location. Then next level comes like connected cars, which we are talking about, that vehicle will start talking to each other. So imagine that like if majority of vehicle is autonomous vehicle, they will start talking each other. They will like moving together. All the vehicles are like well informed. So because now all the vehicles are autonomous vehicle, so they will be basically connected. So like being driver, we keep seeing all the vehicles surrounding, and based on their action, we keep on changing our action. So in that way, like all the vehicle will remain connected. Once they remain connected, so obviously they can move faster. And once one vehicle is going to slow down for some reason, it can inform all subsequent vehicle that the particular vehicle is going to slow down, and immediately brake will be applied. So that way, like they can move much closer, much faster, and much safer. So that will what will happen. So whatever existing road you have, maybe they might able to handle 2000 vehicle per hour. It can handle maybe 3000 vehicle per hour. So that way, like maybe in future you might have like a little bit less congestion issues if the autonomous vehicle started talking to each other and they start making decision together and cooperating each other. So in that scenario, it's not that they will be talking to each other only, they will be talking to the infrastructure as well. So they will be remain connected to a central hub where they will be they will be giving all the information to the particular control center. So you can track each and every vehicle, where they are, what they are doing, whether they are accelerating, decelerating, all the information you are getting. And because now all these, like in that word, imagine that like you are in word of autonomous vehicle. So and which is where the entire 3D model of the city is already fed in. So now you don't require like any physical infrastructure. So maybe like once you go in future, so maybe like at intersections, once you reach, you will not see any signal light, but still your vehicle will stop, because that is like virtually it is present, because in the 3D model it is already inbuilt that a signal is there, and which keep changing its own status. So based on there might be a device, a small device, which keep on emitting information that currently signal is red, this much red time is left before it turns to green. So all the vehicle will keep receiving those information, but being a kind of occupant or being the passenger, you may not realize that there is any signal. But everybody will be like, all the vehicle will be able to visualize those signals, and they will follow that. So that way, like it will be a kind of being, we as a human, we will be in a kind of virtual world where everything is like happening without your knowledge, and then your vehicle is traveling and stopping, following certain rules, but nothing is visible as a physical infrastructure. So that way, like this kind of sometimes like some of those movies comes which like hypothesize this kind of technology where everything is like trackable, everything is following the rule. As soon as you break the rule, you will be get caught immediately. So that way, like things will be much efficient, much disciplined, and so if it is much efficient, you are like may require much resources to run those systems. Then moving ahead, like there might be this has become quite real, where you had to get down and give the money and those things, and then your boom barrier will get open. Now as soon as you reach, if you had the fast tag, automatically it will read and it will get open. So currently, like we need to slow down up to certain extent, but that is actually not the technology limitation. Maybe that kind of instrumentation we are doing is not that up to the accuracy level, or maybe the efficiency is not that high. Otherwise, like if you are keep moving at 50 kilometer, you need not to slow down. Automatically, data will get transferred. So in future, like maybe you will not see any toll booth. Yeah, like as even our honorable minister has already told that like geofencing will be there. Like you, as soon as you enter a particular area, automatically your toll charge will start, and as soon as you go out, automatically the toll will be deducted without any physical like obstacle, or you might not knowing, but like all the tolls will keep deducting if you are utilizing a particular facility. So now many of these cars they had which is like launch after like last year April onwards, they had the GPS inbuilt. So whether you are aware or not, but your vehicle position is always logged, and the automobile industry or owner they know that like where you are. Even once you are traveling, you are continuously tracked. So that way, like those technology is already inbuilt in all new vehicle model, and subsequently the add-on will come with that, like maybe with cheap rate you spend 5,000 and put an instrument, and then it become like kind of trackable. So there are various benefit of this, like maybe even nobody can take your vehicle without your permission. If it go, you can define that, okay, this is the area where your vehicle should be at this time window. So until whenever the vehicle had taken out of that area, automatically alert message will come to your mobile, and from mobile itself, like you can switch off the engine, which cannot be switched on. So that way, like there are like many added advantage of this technology. So this we had already talked about, like where vehicles will be talking to the infrastructure and vehicles will be talking to vehicle itself. So now imagine in these cases, like if all the vehicles are connected and suddenly in one side ambulance started coming. So right now the situation is that if ambulance come, nobody gives way for ambulance, and that like sometimes like these patients has to suffer because of these congestion. But in these kind of places, once like everything is connected, once the ambulance started coming, it all the vehicle will get that information in much beforehand, and they will start creating a space for those kind of emergency vehicle. So then things will be much better in future. So in technology wise, we use these terms more uh, uh, frequently. V2E means vehicle to vehicle communication, vehicle to infrastructure communication. V2X means vehicle to all, including vehicle to infrastructure, all communication. So all these like are going to be available in future, very recent future, maybe next hardly 5 years. So you will be started witnessing this autonomous vehicle, which will be level 3 onwards. So most of the vehicle which comes, like they are up to level 2. So and in Mahindra and something they tried that where if you uh, you switch on your vehicle or maybe you go to the particular autonomous mode, they will follow a particular lane. Even if curve comes, they will navigate through curve. You need not to change your steering. But still lane change and other aspect is still challenging. And getting vehicle are getting assistance at much lower speed and congested stream, it is still a challenge. So those things will get resolved very quickly because now all the vehicles are having a GPS. So now automobile industries started collecting data that how people travel, at what rate they accelerate, decelerate, what rate they brake. All those informations are like getting collected for human behavior or maybe the driver in Indian scenario. So once you have lot many data of that kind of sort, so the building the algorithm over that huge amount of data, then your algorithm becomes reliable. So then autonomous vehicle can be easily developed, which can safely drive in Indian traffic context. So then you can have this kind of traffic management center where all the keep coming. So the entire network, like, and these vehicles will keep sending their information. You can monitor from here. You can, if anybody violates anything, you can book challan without having any physical presence at the ground. So those things are like currently you have traffic management center, but here through camera we are getting the information and we are booking the challan at TMC. So these things we can skip. I think that is all from my side. Yeah, over to you, Anuj.
Yes, sir. Have any query? Please ask. Really ask. Sir. Have any query, please? Thank you, Dr. Akhilesh, sir, for your enlightening session on cutting-edge technologies in transportation. Your insights into VR, AR applications, especially VR simulator for driver behavior analysis, along with advancement in autonomous vehicle, 3D printing, smart parking, sign-based navigation, and modular infrastructure. Challenges with autonomous vehicle were truly inspiring. You have broadened our perspective on how technology can revolutionize mobility and urban planning. Session was uh, both informative and thought-provoking, encouraging participants to delve deeper into these emerging domains. We sincerely appreciate your valuable contribution to this FDP and hope to engage with your expertise again in future. Thank you, sir.
Yeah,
Thank you.
yeah. Anuj, just 1 minute. I think there is one question in chat box from Anita. What is the role? What role can autonomous public transport system play in reducing the carbon footprint? So this is like quite important question. And here, if you have this like autonomous vehicle, especially in public transport mode, which is like running multiple routes throughout the days. And if you had this kind of autonomous vehicle, then you can maintain the kind of schedule very well, and they can be available at a fixed interval. So suddenly, right now, what you will see that suddenly the 5-6 buses come, and the next 15 minutes nobody is come. So monitor and get moving on. And if you see the overall pollution level or efficiency level, once the autonomous vehicle started coming in, not only public transport mode, even private vehicle also, you may see that like there might be a disturbance, maybe some kind of human psychology or maybe fear might come. People may not able to feel comfortable. In those cases, like once you have percentage very low, you may see that like suddenly emission may not reduce. But once the percentage increases, emission is going to reduce because they will not unnecessarily brake, they will not unnecessarily put horn because they will be talking to each other. So their travel trajectory will be much smoother. I hope that I had answered your question, Anita.
Sir, one more question is from the Harshit Gupta. How AVs navigate using GIS data, how traffic pattern are modeled in AI or something else?
Okay. How AV navigate using GIS data? It's not GIS data. It's basically they have this GPS data. They had all the travel trajectory. Like if you are currently all the vehicles are moving, they keep collecting the data, like at what rate people are moving, what ways people are taking lateral shift, right, on different traffic stream. In many cases, they have the ADAS also. So ADAS is also collecting the information that like what kind of distances you are maintaining in Indian traffic context. So these data becomes very crucial in deciding the car following theory, means that how you follow a car, which is leading, which is ahead of you. So in different, in lane-based traffic, a different formulation come. In case of our traffic where lane people does not follow lane, things are quite different. So that way, like this kind of GPS data information and ADAS data information become very important, where you can develop your AI based model or machine learning based model to predict that if this is scenario, what is your driver action. So that kind of question can be quickly answered if you have large number of data. Then how to use AI technology in civil engineering? That is like quite wide open question. Maybe this is not the maybe I can answer, but AI is like wherever you have data, you can use AI. So if you had like large amount of data with the digitization, with the instrumentation, you are getting more and more data, not only in terms of like mobile, or maybe even in all. If you say transportation, there are a lot of cameras are installed. You are tracked. So all those data you are giving me. So I can, with that data, I can figure it out how many people are traveling at a particular time, from place to which place they are traveling an entire day. So I have your entire travel trip from morning to evening. So entire city, I can map that from which place how many trips get generated, and from which where they go, how what mode they use. So that is going to be very helpful in the planning the entire city. I can decide that which road we need to widen, which road I can make it smaller, and where more people are going, how we can divert those people in order to avoid congestion. All these things can be done if you have this kind of data. Okay. So yeah, thank you. Over to
Yes.
you, Anush.
Yes, sir. Thank you, sir.
So thank you, everyone. So maybe if you had any particular query, you can just like drop a mail over to me, and hopefully that like you might have got something meaningful through this session, and keep listening. And thank you, Anuj, for organizing such a nice FTP. And maybe like subsequent days, they will be getting much and more information from different speakers. So thank you all. Bye bye.
Thank you, sir. Thank you, sir. Thank you, sir. Now, today's second eminent speaker, Dr. Chandan MC. He's a assistant professor in the Department of Water Resource and Ocean Engineering at NIT Suratpur. Sir is also joined the meeting.
Hello, sir. Hello. Good evening.
Good evening,
Dr.
sir.
Anuj.
Good evening, sir. Sir hold a PhD from IIT Kharagpur, where his research focus on urban land use modeling and special decision support system for Indian cities. Dr. Chandan sir has prior teaching experience at NIE Mysore and industrial experience as a management trainee at Sova Developers, Bengaluru. His research interests include remote sensing, urban growth modeling, spatial decision systems, urban flood modeling, and urban heat island studies. He has published several peer-reviewed journal articles and book chapter, and has presented his work at national and international forums. He has also received of Best Paper Award and the Sadri Ecologist Award from IIC Bangalore. Sir actively engaged in academic societies. Dr. Chandan sir has member of IEEE GRSS, ISRS, and IMS. His interdisciplinary work bridges civil engineering and geoinformatics, contributing to sustainable urban development. Welcome you, sir. Can you?
Thank you. Thank you so much, Dr. Anuj, for the kind introduction.
Thank you, sir.
Let me start the session. Please let me know if my screen is visible to you.
Still no, sir. Now is okay.
Okay. Am I clear? My audio is clear?
Audio is okay, sir. What screen is not visible clear. Maybe double click to enter screen mode.
Okay.
Now is okay, sir.
Is it fine?
Yes, sir. Yes, sir.
Okay.
Thank
A
you,
very
sir.
good evening to all of you. Myself, Chandan. I completed my PhD from IIT Kharagpur in 2020. And for the next 40 minutes or so, we are going to have a brief look at the urban infrastructure mapping from a geoinformatics point of view. So when I speak about the urban infrastructure, basically, if you see the Indian setup, we have cities which are classified as metropolitan cities, tier 1 cities, tier 2 cities, towns, villages, hamlets, etc. So in this session, we are going to quickly understand how this setting can be seen spatially, that is from a satellite. So in this particular image, if you see, this is basically, we call it as a time lapse. Many of you are already aware of Google Earth Engine. It's a very powerful, um, platform to visualize the Earth monitoring and how the changes are happening on the Earth's surface on a day-to-day basis. Why this image is interesting is because you see, starting from 1980s to recent year data, satellite data. This particular place is actually the Saudi Arabia, you can see here. And there they're already doing the sustainable irrigation practices, okay, in the desert. So how do we visualize this? This is one of the many examples what is already available in Google Earth Engine. So it is a very, very powerful tool. So why I am specifically focusing on this is because today we have the satellite data at our fingertips, and we just have huge data sets which are already available for free. Only thing is, we should know how to use this data judiciously for our research purpose. At this point of time, I would like to give one question to the audience. Can anybody answer how many number of satellites are orbiting around our Earth as on date? Any number? Take a guess. You might be wrong, that is okay. How many number of satellites are active and they're revolving around the Earth as on date 2025, what we are speaking? How many number of satellites do you think? You can also uh, unmute yourself if it is allowed. Okay. Any guess? Any answers? Okay. So basically, as on date, around 12,000 and odd satellites are present in the orbit. Okay. And if you go back just 4 or 5 years, 2021, it was around 6,500 satellites. Just in the span of 4 years. Okay. Elon Musk has added n number of satellites into the orbit. Why I am saying this is because when you see the technology which is happening today, again, I would like to stress about the data what we are getting. Moving ahead, how do we use this data? So how do we use the geospatial data in our day-to-day lives? So basically, all of you are using the navigation apps, that is Google Maps. Maurya sir was in the last session, he was speaking about traffic management and other things. So nowadays, it is playing a very big role in the navigation also. Then governance, e-governance. So today, you don't have to wait for election results to appear in the next day newspaper. So instantly, you can very much visualize in your mobile phones in which area, which party has come into the power and etc. And if you see from the morning till evening, we have been using the geoinformatics and geospatial data in the background with knowing or without knowing. So maybe the service and delivery platforms like Ola, Uber, Swiggy, etc. You are all using it in your day-to-day lives. And we also have many decision support systems. Here I have given one such example, that is Krishi Decision Support System, which was recently launched by our Ministry of Agriculture. So which is giving a real-time feedback to all the farmers about the crop mapping, etc. So why do we want to study the urban areas is the question. So the need to understand this urban dynamics is that already we know that the pre-existing metropolitan cities such as it can be the Mumbai or Kolkata or Delhi, they've already saturated both in terms of natural resources utilization as well as population. So the newer urban agglomerations such as Ahmedabad, Hyderabad, and Pune, they are picking up the pace. And you see, the illegal land acquisition is becoming a very big challenge for the local authorities to handle and to control the urban sprawl, which is happening in the periphery of the system, has become very difficult. So this calls for an immediate planning and visualization, which is very much important. Then we have to see the changes in the environmental health. That is why the United Nations is focusing mainly on the sustainability, sustainable development goals. There are 17 number of sustainable development goals. If you closely look at, we have the goal number 9, that is industry, innovation and infrastructure, and goal number 11, that is sustainable cities and communities, which matter the most with respect to urban communities. So with this, if you see the picture to the right, this is the nighttime imagery for Indian subcontinent. You can see within a span of just 4 years how the transformation has happened, and what challenges do we have? We already have huge data sets which are already available, but retrieval is the main challenge wherein it has become a hindrance. And for this, we need to develop the spatiotemporal patterns of various cities of India. And this can be accessed by anyone sitting in any corner of the country with the system called a spatial decision support system is what we work on. If you see where the data comes, so basically our geospatial data acquisition starts from the field, right? And when we look at the spatial data acquisition, we have two methods. One is the ground-based acquisition method. Here onto the right side, you can see wherein we have a DGPS which is placed, and we can obtain the coordinates of a particular place, or we can even route our UAVs to DGPS, and thereby we can do the flight planning and collect the spatial data. And we also have land surveying in the form of total station. Earlier, we used to use the theodolites, but now the theodolites are obsolete. So we are going for the total station with GPS, the latest models, robotic total station, which can also give you real-time updates on the coordinates that are measured in the ground. Then we have the laboratory measurements of samples, measurements in the in-situ sensors, etc. And if you see the image-based acquisition, basically in today's era, we are focused on the image-based acquisition, such as the drones and the sensors that are available on the drones. So here, this was the part of one of the exercises what we conducted of the campus survey using the aerial cameras and the drones. And also we can use for high quality data, such as the radar data and LiDAR data. And other source of data is the Survey of India. So what Survey of India will give you is it will give you free maps. Okay, that is the topographic maps of 1:50,000 scale. Now you might ask me, what about the other scale? 1:25,000, 1:250,000, 1:10,000, in fact, is also available with the Survey of India, but you need to register and pay a nominal fee. Then only you can get all the topo sheets for free. And if you see the second, that is, we have the United States Geological Survey, that is what we call it as USGS. So in the USGS, we can have the longest running Earth observation mission, that is Landsat series. So Landsat 1, as you all know, started from 1972. And we have the Landsat 9, which was launched very recently. And if you see, this is Landsat 8 characteristics. We had a total 11 number of bands, which we call it as spectral resolution. And starting from the blue band or the coastal aerosol for aerosol mapping and studies, to the thermal infrared sensors, we have total 11 number of bands which are being designated in various wavelengths. And each of these band has very specific application on the Earth surface. So next is we have the Bhuvan and Bhunidhi. So basically this is maintained by the NRSC, that is National Remote Sensing Center, ISRO Hyderabad. So what do we get in Bhuvan and Bhunidhi is that you will get free satellite data of resolution up to 23.5 meters. And of course, you have LIS4, which is 5.8 meters. You just have to register in the NRSC portal to get these data sets at your dispense. And we also have a number of vector data points in terms of point, line, and polygons. State-wise remote sensing portals are also linked in this Bhuvan. So you can just explore this for more data sets. Then we have OpenStreetMaps, wherein we can have the vector data points. Okay, so in terms of points, whether we have certain hospitals in the vicinity, schools, colleges, etc. Lines such as the roads, nalas, and the river, etc. Then polygons in terms of designated areas and other things. Then we have Google Earth, which can give you free vector data points. Again, this is also very unique. We have the point, line, and polygons. 3D buildings can be obtained for a limited area in Google Earth. And if you see, the most powerful platform today is called as Google Earth Engine. Why I am calling it as the most powerful platform, and this particular image, what you see on the right, is the most powerful image, of course. Why? Because it is a composite of many images held together, which is giving you the climate dynamics starting from 1990s to the recent 2023. So basically, this is a surface to air temperature model, which is having n number of satellite data sets within the span of 1990s to 2023. So how to analyze this huge data? That is the question. So if you want to download each and every tile, so basically a satellite image, let us say it can capture around 175 kilometer by 175 kilometer grid. So if you go by that, so the grid which is required for one single year, let us say, that itself will run for some 100 or 200 images. Then what about all other years? And this is basically a monthly average image. So if you see all those images, it will run into uh, millions of bits of data. So to hold this image together, it is not at all possible with your own desktop or laptop systems. So a Google cloud-based platform, which is called as Google Earth Engine, which carries a petabyte, multi-petabyte catalog of satellite imagery. So this you can log in and analyze on the go, whether if you want to see the rainfall pattern for your area, or temperature pattern for your area, or how it is changing over the years. It is all possible within a click. You don't have to download any software. Then coming to the urban area and urban area specific applications. So as we all know, the urban area is defined by the levels of changes, how it has been changed for over the years. And the definition also, if you see, it varies from one country to another country. And earlier days, if we see, humans started settling adjacent to rivers, that is how the colonies formed. And then small villages, villages to towns, towns to cities. And today we are in the very complex urban ecosystem. That is what we call it as metropolis. And if you look at the term urban sprawl, so basically this is the low density urban settlements. Generally, this happens to be in the outskirts of a city. So it is also in the polycentric urban pattern. And we can identify it as a three major type of urban sprawl. One is called as the low density sprawl, ribbon sprawl, and leapfrog sprawl. The other type include the edge expansion and spontaneous growth. Now, after this slide, I am going to put a question to you. For example, now I think I am talking to Rajshree Institute of Technology. Let us say it is in Bareilly, UP. So after this slide, I will give you some examples. You should tell me how the Bareilly is experiencing the urban sprawl or urbanization. So here, this animation will give you much detail. The first one is called as the low density sprawl or the infill. So here, Bangalore, you can take it as an example. Then ribbon sprawl, Delhi. Leapfrog is Mumbai. Edge expansion is Chandigarh. And spontaneous is Ahmedabad. What is low density or infill? That means first, this central business district will be covered with urbanization. It will be saturated. Then eventually, slowly, the urban area will start growing outside. Then ribbon sprawl. What do you mean by ribbon sprawl? Ribbon sprawl means if you take Delhi, there are many areas like Ghaziabad, Faridabad, etc., Noida, which are in the outskirts of the CBD. So this is called as a ribbon sprawl. Then if you take the example of the leapfrog, for example, Mumbai is actually an area where you have many restrictions. If you see the Mumbai's geography, it is surrounded by ocean on the one side, and on the other side you have a river delta, and you have the forest. So there is very less scope for development. So that is why we call it as a leapfrog. Leapfrog means how a frog jumps from one place to another place. That is what the fashion we are seeing with respect to Mumbai. Mumbai to Navi Mumbai, we are seeing a jump of urban areas. Then we have the edge expansion. What is edge expansion? Generally, if you see the setup of a city, the central business district like Chandigarh, it doesn't have enough space to further development, because Chandigarh is a very well planned city. Same is the case for Naya Raipur. So when you see these kind of cities, eventually the cities will grow outside. That is why it is called as edge growth. And then we have the last kind of the urban expansion, which is called as the spontaneous growth. In case of Ahmedabad, there are many cities which are experiencing spontaneous growth. Ahmedabad is one such. We have Hyderabad also, which is also experiencing spontaneous growth. Now question to you audience is, out of these 5 types of urban growth, wherever you are belonging, so that is, for example, you are belonging to your Bareilly in UP. So can you tell me what kind of urban growth your Bareilly is experiencing? Any answers? Bareilly definitely is not leapfrog because you don't have any restriction on growth. So I want to understand whether it is a low density or a ribbon kind of a sprawl. I actually don't know what is the exact setup of Bareilly city. So please try to understand from this point of view so that you will understand how urban planning can be made. Okay. Then if you see this major cities of India, we considered around 10 cities for our analysis, how it has changed over a period of time. Out of this, the 3 cities were Delhi, Kolkata, and Mumbai, which were the already metropolitan cities by size. Of course, we also have Chennai and Bangalore, which is at the verge of getting that classification. And we also had upcoming cities, major cities like Ahmedabad, Bhopal, Coimbatore, Pune, etc. And if you see this slides is very interesting because it gives the transition of almost all the cities what we speak in the last slide for nearly around 3 decades, starting from 1990 up to the very recent 2017 or 2019. And if you see here, it has been classified into 3 groups. You can see in the bracket G, and there is M, and there is R. What is this G, M, and R? That means G means it is the gradual transition, M means it is the moderate transition, and R means it is the rapid transition. So how do we identify this? This is basically set based on threshold of urban area which is experiencing in that particular region. For example, if I take Ahmedabad during 1990 and 2017, during 1990, the urban area was only 7.03 percentage. Whereas if you see in the year 2017, Ahmedabad already had 19.35%. And recent updated studies says that it has almost crossed 24% of urban area in Ahmedabad. So it is a gradual transition. Similarly, if you take one more example of medium or moderate transition, here you can see the Bhopal, which is in the Madhya Pradesh. So Bhopal is having a moderate transition starting from 1992 to 2017 and the very recent 2024. 1992, the total urban area was only around 0.93% of whatever the circle you are seeing here. And in the year 2017, it is around 8.71%. Similarly, one more example, if you take of rapid transition, uh, for example, Chennai. So Chennai has experienced rapid transition. So this is basically, you can visualize also in the form of the land use map, what you are seeing here. The red shows the urban area and urban density, of course. So during the 1990s, it was only 0.46%. And today in Chennai, we are already seeing around 25% of urban area. So now, if we want to predict how our urban areas are going to be in the future, so that is called as urban growth model. So the urban growth model basically speaks about the complex interrelationships between the natural ecosystem and the urban environment by observing the heterogeneous patterns of change. Why we call it as heterogeneous is because within a city, there will not be only urban, there will be some natural landscapes, there will be some water bodies, lakes, rivers. Some cases in the coastal cities, we also have ocean, etc. So that is why we call it as a heterogeneous patch. Then, when we look at the literature, models have been adopted to predict future urban growth using simple transition rules. If you see the cellular automata, the grand cellular automation, what we call it, along with the Markov chain. So that will give you based on very simple transition rule. But actually speaking, what you need is a stochastic optimized process which can detect how the future urban growth is going to be based on the past trends. So for that matter, we are having a series of urban growth models which can be falling in 5 different categories. One is we call it the classical theories of artificial life, under which we have the cellular automation and Markov chain agent-based model, and we have certain swarm-based intelligence model such as ant colony optimization, bee colony optimization, etc. Then we have the intelligent stochastic optimization process, such as it is a combination of one or two models. So here we have the genetic algorithm, which is combined with the sleuth. Sleuth stands for slope, land use, elevation, urban transportation, hillshade, and simulated annealing. Then we have the evolution computing. Most of our AI and ML falls into this category, that is artificial neural network and spatial DNA. Then we have the knowledge-based intelligence systems, under which we have the fuzzy logic, expert system, heuristic search, and reasoning system. Then we have the hybrid AI system. Hybrid AI system means it is a combination of multiple systems uh, by which we can predict the urban growth. Now, if you see specifically, I'm going to the sleuth model. So sleuth basically is a cellular automata based model, which was developed by Professor Casey Clark. And why it is so unique is because it has 5 different parameters: diffusion, breed, spread, slope resistance, and road gravity. Why only these 5 parameters is because these 5 parameters will generally guide the urban growth, how it is going to be in the future. And these parameters can have values ranging from 0 to 100. And sleuth generally what it does is it runs a calibration to find out for each of this parameter what is the best suited value between 0 and 100. For example, diffusion, if I take for Bareilly diffusion, the best suited value for Bareilly diffusion can be 62, breed can be 68, slope resistance can be 30, road gravity can be 82. Okay, but how do I find what is best for Bareilly? That is point number one. Once you find out what is best for Bareilly, might not be the same for Lucknow. Because if you see Indian cities, it is not like United States cities. United States, it is very much, United States cities did not exist in 1700s or 1800s. It started only after 1800. But what about our cities? If you see Kolkata, if you see New Delhi, those are all the cities which is there from much before that time, and already people had settled there. But United States cities, it was developed afterwards. So you cannot fix a particular value for a city, and it has to be done using a typical calibration method. So after fixing the parameters, we also have certain coefficients which the model will take care, such as the spontaneous growth, new spreading growth, edge growth. We already spoke about the spontaneous growth and edge growth, and also the road influence growth. Suppose if I want to exercise the sleuth on one of the area, this is the input data set which we need. So here I've given one example for a part of Chandigarh. So we need the slope layer, land use for 2 different time period. Here I have considered land use for 1999 and land use for 2017. And we need the urban area for 4 different time periods: 1990, 99, 2009, and 2017. Similarly, we need the road network: 1990, 99, 2009, and 2017. If you are wondering why I have not considered the recent data, it is already done, but I am yet to compile that. Okay, fine. You understand that slope comes from DEM, that is digital elevation model. Land use comes from Landsat data. From the land use map, we can derive urban data. But can you tell me how the road data is derived? Anyone in the entire participants, can you tell me how you can take the road data? For example, here I am showing you the road data starting from 1990, 99, 2009, and 2017, or maybe 2025. So 2025, how I can take the road data, where I will get? Suppose, let us say you want to do for Bareilly and Lucknow. How you will get the road data? Any answers? You can unmute yourself if it is permitted, or you can put your answers in the chat box also. Any answers? How can I get the road data for your city in the year 2025? If you can answer this question, then you can easily answer how you can get the 1990 data. Okay, fine. So 2025 data can be downloaded directly from OSM, or if you are not aware of OSM, you can simply use QGIS, and there is a plugin called OpenStreetMap plugin integrator. So you can download that and you can install that. Then you can derive the road for your region. Once you get 2025 data, then you have to back work. Nobody is going to give you 2017 road, 2009 road, 1990 road. No one has the data. So what you will do is you will overlay or superimpose the 2025 data on the 1990 land use map, and you will try to delineate the roads. Similarly, we have excluded layer, which is excluded means which is excluded from future urbanization. Suppose here there is a river and here there is a lake. So that lake can never become urban area unless it is from Bangalore. In Bangalore, people are already covering the lakes with soil and they're building some, apartments and everything. That is a anyway different topic. So you are not supposed to plan like that. Then we have the hillshade. And now if you see how the sleuth model works, so basically initial conditions are given in terms of layers. That is the input layers what we speak. Then we have a scenario file, which is like the containing all the information of the details of the city. And then we have the path and the log files, coefficient setting, the parameter setting, etc. Why? Because we need to understand, suppose let us say, for example, if I take Chandigarh, I don't know for all the 5 parameters, what are the best values for Chandigarh city, diffusion, breed, spread, etc. So what I'll do is I'll go to the calibration phase. In calibration phase, I'll first calibrate it for the very coarse image of 120-meter resolution. Then I will calibrate for 60 meters. Then I will calibrate for 30 meters. So this is the regular routine. It is a very detailed calibration procedure. Then I will start with the output prediction. Okay. So output, how I'll be able to see? I'll be able to see the output in terms of image. That is one, and also the statistics. So therefore, I can predict what is going to happen for 2025, what is going to happen for 2030, etc. Where the growth is. And if you see connecting to Ludhiana and other important places, here we are experiencing the spreading growth. And mind you, this result is for 2030 and how it can be seen. Then image B, if we take, so this is we have the road gravity, which is the influencing factor. And Chandigarh region, we have one eco city which is coming up, and it is also the roads like Kurali Chandigarh highway road, which is influencing. Then if you see the another type of a growth, which is organic kind of a growth. Why we are calling it as organic kind of a growth is because of mainly the patches which are very organic in nature. So here you can see the nearby areas, Pinjore and Kalka region. So why the growth is happening beyond the Shivalik range is because there is a tourist attraction, the Kaushalya Reservoir, and the connectivity is good. We have NH22. Further, it is connecting to Shimla and all other places also. Then we have the diffusive growth, just outskirts of the Chandigarh city. If you see, we have the Chandigarh International Airport and Zirakpur and JLPL industrial area. So here we can see the diffusive kind of a growth. So similar analysis was conducted for almost all the major cities of India, and this is what the trend that we observed, how it is going to be for 2025. And majority of the 2025, what you see today is also true with respect to the urban area. To put everything in one portal in India, that is the thing what we are facing today. Many researchers are doing the research, but the data what they're getting, they're all in isolation. If I do the analysis, I am not giving data to anyone. So to avoid this, what we have done is we have given a portal which is called as SWOT. SWOT stands for Spatial Web-Based Analysis of Urban Transition. If you want to visit this site, you are welcome to visit this. Just type swaut.co.in. Anyway, I'm going to show you one demonstration of this website at the end of this session. So meanwhile, if you are interested, you can just type in swaut.co.in, wherein I have put majority of the data sets, whatever you saw for all the 10 cities of India. You can also do modeling on the go. That means you don't have to download any softwares for that. You are free to use the SWOT website and you can run the model. Currently, we did a research very recently for the Bangalore-Mysore Expressway corridor. Basically, the Bangalore-Mysore Expressway corridor is around 120 kilometer stretch, 10-lane expressway road. So we just wanted to analyze with this expressway coming into picture, how the nearby landscapes are changing, especially with respect to urban landscape, what kind of growth you are going to see in various regions. So that is one exercise what we conducted. And also currently the research is going on with respect to the groundwater potential mapping. And many of my PhD students are working on climate change and its impact on urban floods and agriculture, climate change impacts, agriculture field validation, because nowadays we all have a lot of data sets which are available. So we are trying to connect that in that aspect. And this is what is the result what we got for the Mysore and Mandya region in Karnataka for the groundwater potential zones in the urban area especially. So we used analytical hierarchical process as well as machine learning techniques to detect that. And moving ahead, if you look at the next 5 or 10 years, I would be calling it as a super tech era, because every day is a day of innovation. You see, just if you go back 3 or 4 years, we didn't have ChatGPT. While I was doing my PhD in 2020, I didn't have ChatGPT. But many of you who are doing your PhD or maybe any other kind of research, you can use ChatGPT, but please use it very resourcefully. Okay, so and it has a tremendous potential with respect to the coding part and data what you are taking from it. And next level of technology is going to be in geospatial AI, that is called as Geo AI, drones, mapping services, and of course autonomous vehicles. Already, our Ministry of Agriculture has launched schemes with respect to smart drones. And Drone Didi is one of the example where the drones are reaching the village women for empowering them. And if you are thinking whether if you're doing your MTech, or if you have already completed your MTech and if you're trying to do your PhD, this is not a technical slide. Just I'm highlighting whether you want to really do a PhD or not. If you are just trying to have a DR in as a suffix, sorry, as a prefix in your name, don't do a PhD. And if you think it is going to be over in 3 years, no, please do not do a PhD. Why I'm saying this is because PhD means you are already diving into a topic very deeper. So please think clearly much before taking up a PhD if you have not yet done the PhD. Then many of the supports are already available in the form of PhD grants. For example, if you see, we have the DST and DBT, and now it has been converted into ANRF. You can apply for that fellowship as well. We have the uh, in Indo science collaboration, India with abroad, like Alexander Humboldt with Germany, Indo-US ST Forum, and Fulbright fellowships, etc. So these are some of the portals where you can actually get the funding for your further research work. Not only for PhD, you can also get for postdoc. Then so far, if you see my journey in the research field, particularly with respect to urban growth and urban patterns in India, has been very interesting. We have also published numerous book chapters and papers. You can go through this. I would like to end my talk here. So if you have any queries or questions, I would like to take it up. Uh, uh, any queries? There is one query from Dr. Ashish. Sir, can we evaluate urban sprawl can drawn from heterogeneous cities where population is not situated orderly? Yes, yes, definitely we can do this. That is what we call it as a urban sprawl, right? Why? Because the population distribution is not unique, right? So that is also possible. We can definitely identify. So basically, we call it as unplanned settlements. So in the layman language, if you want to call it, we can call it as slum, or we can call it as unplanned settlements. That is one of the area where we are also working, where the population is not situated orderly, as you rightly said. Any other queries, participants?
Have any other queries? Please ask directly or either text box, please. Okay. Thank you, Chandan sir, for your highly informative session on urban infrastructure mapping, a geoinformatic detailed explanation of geospatial data acquisition, characteristics of landscape imaginary, and its application in analyzing urban sprawl provided great insight into modern urban planning techniques. The introduction to BEV, a waste spatial decision support system, added immense value, highlighting the role of GIS in data-driven urban infrastructure development. This session enriched our understanding of how informating can support sustainable and efficient cities planning. We are grateful for your valuable contribution.
Yeah, Dr. Anuj, thank you so much for that opportunity given for me to speak to the varied audience. And I would also like to suggest those who are looking. Department is open. We have three branches. We have marine structures, we have water resource engineering, and also we have remote sensing and GIS, wherein the prospective students can look upon us for your MTech as well as PhD. You are welcome to do research in our institute, NITK Surathkal. So, thank you.
Thank you. Thank you. Thank you, sir.
Praveen says showing the demo for SWOT. Just give me a minute.
Okay.
I just have to set up. Just a minute. Yeah, please give me a minute. I'm just connecting so that. Yeah, Dr. Anuj, I'm facing from server issue. Anyway, I'll try to check again.
Yes, sir.
So basically, this is the website swaut.co.in. Currently, I'm facing the server issue. It is not loading. But anyway, once that is up and running, you can definitely have a look at this spatial web-based analysis for urban transition. That is in short called as SWOT, swot.co.in. So yeah, I'll definitely keep you updated on that. Are there any other questions?
Okay.
Thank you, Dr. Anuj. Thank you
Thank you,
very
sir.
much.
Thank you, sir. Now, as we conclude the first day of our 5 days faculty development program on recent advancement in civil engineering, I extend heartfelt thanks to our additional speaker, Dr. Akhilesh Kumar Maurya, sir, and Chandan MC, sir, for their enlightening session. Their insights into emerging technologies from AR, VR, and autonomous system to geospatial data and urban planning have laid a strong foundation for the days ahead. I also appreciate the active participation and enthusiasm of all attendees. Let us carry forward for momentum, continue learning, and engaging deeply with the knowledge shared. Looking forward to your continued involvement in the upcoming session. Thank you. Thank you to all. Thank you once again, Chandan sir.
Thank you, sir. Thank you so much.
Thank you,
Can I
sir.
leave or is there
Yes, sir.
anything
Yes,
else?
sir. Thank you, sir.
Okay, thank you. Thank you, sir.
Thanks to all. Please leave this session. Please. We will make tomorrow on at 2 to 3 p.m. and 3 to 4 p.m. tomorrow. Okay, thank you all the